Okay, so welcome to 6.1 and 6.2 Properties of Exponents and Polynomial Functions. The first part of this, we're going to talk about properties of exponents. It's something you probably already had. You've already used, maybe you haven't used the explicit rules and had the rules defined to you, but you have used them before. First thing we're going to talk about are breaking down what a base and an exponent are. If you look in, here we have a base x and an exponent of 3. If we put this whole thing together, we call it a power. So we're going to call this whole thing, when used together, is a power. And I'll refer to that whole quantity as a power from now on, with the base being the purple part and the exponent being the red part. So if we scroll down, we can see our different rules. So starting off, we have the product rule. And the product rule just says if you have two powers multiplied together with the same base, I don't have my little asterisk up here, so let me throw it on here. So I have this rule applies to the product and the quotient rule. If you look up top here, I have a little asterisk. These bases have to have the same base in order for these properties to apply. So for the product rule, I have two powers with the same base multiplied together. When that happens, I add exponents. So in this case, I have x to the a times x to the b, and I get x to the a plus b. And if you look over at the example says x squared times x to the 6 times b squared. Because the x squared and x to the 6 have the same base, I can rewrite that as x to the 2 plus 6. But because the b is a different base, I have to leave that the same. I can't combine that. And then that becomes x to the 8th b squared. Next is the quotient rule. The quotient rule says that if you have two powers divided, one divided by the other, with the same base, then instead of adding exponents like you do in the product rule, you subtract exponents like you do with an inverse. So for instance, the product rule is the inverse of the quotient rule, or multiplication is the inverse of division. So it only makes sense that we're going to do the inverse operation. Product was addition, quotient is subtraction. So x to the a divided by x to the b is going to give me x to the a minus b. And if you look at the example, you have a squared b to the negative 1 divided by a to the negative 2 b to the third. Don't let the negative exponents throw you off. This just becomes a squared. Scroll down so I can write here. This becomes a to the 2 minus a negative 2. And then it becomes b to the negative 1 minus 3. So now we write this is a to the 2 plus 2, so it changes to a to the 4th, b to the negative 4th. The next one is a power of a power. And the power of a power just says when you're multiplying these exponents, you have a power raised to another power, not multiplied by another power, but raised to another exponent, I should say. So in this case, we have x to the a, the entire quantity raised to the b power. So when that happens, you multiply the exponents. So this will become x to the a times b. And in the example, we have y to the third, the entire quantity raised to the 5th. And I just multiply those exponents, and I get y to the 15th. And this comes from the fact that exponents are actually repeated multiplication. Y to the third, the entire quantity raised to the 5th, just tells me that I take y to the third times itself 5 times. So let me just write this out here so you can see it. Y to the third times y to the third times y to the third times y to the third, and one more time. There's 5 y to the thirds. Well, now I can use the product rule, and I see that I have y to the third times y to the third, so on and so forth. I have the same base, so I'm going to add exponents. Well, it's 3 plus 3 plus 3 plus 3 plus 3, or 3 times 5. So y to the 15th. power of a product rule. This is just an extension of the power of a power, and this just says that if you have things multiplied together inside these parentheses and the whole thing is raised to a power, it's kind of like you distribute that power. So I have to make sure the x is raised to that power, the y is raised to that power, and the z are all raised to that power. In this case, the power is a. So the quantity x, y, z raised to the a power becomes x to the a, y to the a, z to the a. And if you look at the example, the one thing I want you to watch is this this 3, I'm sorry, gets distributed to the -2. So the -2 is raised to the third power also. Okay, it's not just it's not just -2x to the third raised to the third power. It's -2x raised to the third power, and then x to the third raised to the third power, and so on and so forth. So that's just a common mistake that people make. Just be careful about that. Power of a quotient is another extension, and this is just saying that if I have a quotient or a fraction raised to a power, then it's the same thing as raising the numerator to the same power and the denominator to the same power. And this example is actually wrong. This should be 4 to the third, which is 64. So let me go ahead and change that. And then that can be simplified, but I'm not worried about it. So if you just look at this, it's a real simple example. If I had something like 1/2, and that was raised to the third power. Again, this is just repeated multiplication, so it's the same thing as 1/2 times 1/2 times 1/2. Or I could write that as 1 cubed, because it's 1 times 1 times 1 over 2 cubed. So it's like that exponent is distributed to the numerator and the denominator. The easiest rule to remember is the zero exponent rule, and that just says that anything raised to the 0 power is 1. Anything raised to the 0 power is 1. And if you need me to prove that, I can, but I'm not going to go through that right now. Negative exponents, these can be a little tricky, but just think about reciprocals when you hear negative exponents. So when you see a negative exponent, you're going to take whatever base it's attached to, and you're going to flip the whole thing over the fraction bar. So like as example here, I have x to the -1. Remember that anything can be written as a fraction. So now I just take that x and I flip it over the fraction bar, and I change the exponent. So now it becomes positive. And the same thing here, this 3 to the -4, I'll move that to the bottom. So I have 3 to the -4 x squared y to the third, and that's technically all over 1. So my next step will be to take this 3 to the -4th and move it to the bottom. So I'm going to move it down to the bottom, and I'm going to change the sign. So it becomes x squared y cubed. I don't move those because they're positive, over 3 to the 4th. And you would simplify this even more and find out what 3 to the 4th equals, but again, I'm not really worried about that. It would be 81 though. Actually, let's make it 81. There we go. That would be your final answer. Okay, so we're finished with 6.1. That's quick and easy. Now we're going to move on to 6.2. But I'm going to stop this video and start a new one so you can, be good with that.